Okay guys, in this video we're going to be looking at, given the equation of a parabola, either in standard form or general form, could we go and sketch it, but also determine the values of the vertex, the focus, the directrix, and even the axis. And so the name of the game is going to be that we want these equations to be written in the standard form of the equation of a parabola first. And so we're going to list both forms of this equation given either a vertical or a horizontally oriented axis. But remember that if it's vertical, we're squaring the x term on the left side of the equation. So x minus h squared, that's going to be equal to 4p times y minus k to the first. Whereas if we have a horizontally oriented axis, we have y minus k being the squared term, and the x minus h is on the right-hand side to the first power here. And so looking at this, some things that we do definitely want to identify, we say that the vertex is definitely going to be at h and k here. With respect to the focus and directrix, I'm not going to generalize those here. We're going to say more along the lines of, once we get it into the standard form, we'll draw what we know and then work from there. So looking at number 18 here, the very first thing I want you to notice is that this equation does not yet look like this standard form. And so what do I want to kind of point out to you as one of the key characteristics of the standard form of an equation of a parabola? And that would be that out of both of the variable types here you see in this equation, x and y, only one of them is of a squared type. And that is to say that we have an x squared here, but we do not also have a y squared anywhere. It's only x being squared. And so if there's any advice I could give you, is that if there is a squared variable type, or whichever one is the squared variable type, we're going to isolate it and all instances of itself on the left-hand side. That is to say that if there was an x squared plus a 2x here, I would keep the x squared and the 2x over on the left-hand side, because this is the variable that we can write as a squared type. And then everything else I would just kind of transplant over to the right side. So this being said, I would basically start by acknowledging that, well, if x is my squared variable type, then y is not of this type. And so what we're going to do is we're going to stash y on the other side of this equation here. And so we're going to take this term and subtract it from both sides, essentially move it over to the right side. So what we're going to get here is this idea that x squared is equal to negative 6y. Now, I have to ask myself, does this really look like either of these forms? And what I'm going to tell you is it actually does look like this first form right here. It's just that what would the values of h and k have to be in order for them to be completely missing from this expression? And I would argue that h and k would both have to be 0. That is, I could write this equation as x minus 0 squared equals 4p y minus 0. Now in terms of what I have out in front here, this is the other important part of this. And so actually, let's just do this first. Let's identify that the vertex is at 0, 0, now that we have this in standard form. The next thing up is going to be determining the value of p. And see, the thing here is when you look at this form, we don't instantly know the value of p a lot of the time, but we do know the value of 4 times p. And so we're going to say that whatever this coefficient is out in front here, that's equal to 4p. So I'll go ahead and set these equal to one another. And by solving this, we get negative 6 over 4, which we are always responsible for simplifying if we can, but we get negative 3 halves. And so in this case, we know the p-value, but why is this important? Well, that's going to help us determine where our focus and directrix lie with respect to our vertex. So let's go ahead and start with this. Our vertex, we want to draw what we already know, is at 0, 0. Other things that I already know from this are, because x is being the squared variable type here, I know that my axis must run vertically. And so the axis of this parabola must go through this vertex value here. And in this case, in particular, it has this x equals 0 equation values. So I am actually going to amend this to my list here, but we're going to say the axis is at x equals 0. Some other things that we would know about this are, because this is my vertex and this is my axis, the focus also has to lie on my axis. And so we say, well, where would the focus lie? Well, it's either going to be up or down by p units. And the fact that p was negative 1.5 here would mean, because p is a directed distance, we're going to go down 1.5 units from here, and we're going to place our focus. And so I'm going to call this my focus here. And we say that if I knew that this was 0, 0 was my vertex, where would the focus be? Well, I would be down 0.5 unit from the vertex. So two ways I can write this. One way to do it is to say, using my vertex values, I'm just going to take 1.5 off of my y value of my vertex, because I'm going vertically downward by a distance of p here. But we could also write it as just 0, negative 1.5, which is indeed the point that it is there. And we would, of course, simplify anything like this to be into this form anyways. And so we say this is 0, comma, negative 1.5. Now at the same time, we have to find our directrix. But knowing that the vertex, which is a point that's on this parabola, has to be the same distance from the focus as it is from the directrix, And also knowing that the directrix runs perpendicular to the axis, we could say that if we were to go up from the vertex 1.5 units, then we would know that our directrix must lie at a height of 1.5 units off the ground. Now, in terms of how I know that it's 1.5 units off the ground, it's because we started at a height of 0. We went p units upward from the vertex here. So we're going to say that the directrix is given by the equation y equals 1.5. And in terms of finding these two things, you could see that we had to start with the vertex, but then use our p value to move along the axis to find these two values right here. So again, once you find the vertex, the real name of the game is going to be to find p and write down what you know in order to determine the rest of these things. I would encourage you to go ahead and finish drawing the rest of your parabola, and we just want to see that it opens generally in the direction of the focus here. It doesn't have to be beautiful or drawn to scale. So number 16, looking at this, we say, well, does this look like any of our standard form equations? And I would say that, it kind of does. I mean, we have this x term being squared here, and it looks like x minus h squared. We even have a coefficient of this y plus 2 term to the first power. The only difference that I see is that the x squared term should be on the left side by itself. So we're going to keep the x variable type on the left-hand side, which means all of this term right here, we're going to subtract it over to the other side. And so what we end up with in standard form then is x minus 1 squared, but is equal to 8y plus 2, and I better put a negative in front of this 8 because we moved this entire term over to the right side. So with respect to what I would be able to tell you about this, let's go ahead and start with your vertex. Your vertex is at h and k. H is always bundled with x, and k always bundled with y. And so in this instance here, we have positive 1, negative 2. And I'm instantly going to go right 1 and down 2 and draw this on my picture here. So this is my vertex. Now, some other things. Because x is the term that's being squared here, not scared, but squared, let's go ahead and run a vertical axis through our parabola here. And so this axis would be at x equals 1. We can confirm this visually here. We say x equals 1. At the same time, we know that we need to find p next in order to determine where the focus and the directrix lie. So keep in mind that this thing right here is 4p. If 4p is equal to negative 8, some things I instantly notice are that I get a negative answer. I get negative 2. And so what that means is to get to my focus, instead of going up 2, I'm going to go down 2 from the vertex, and that puts our focal point then. If the vertex is at 1 comma negative 2, this would put us 2 units down from 1 comma negative 2 at 1 comma negative 4. And so two ways you can write your focal point here. You can write, I left my vertex and I went by p units off of my y value there, or we could just write it as 1 comma negative 4, which is the simplified way anyways here. Because we had to go p units down from the vertex to get to the focus, we have to go p units up to get the other direction to get to our directrix. So that means then our directrix would run perpendicular to our axis here, and in this particular case, it's 2 units up from a height of negative 2, and so we're saying at a height of 0. So with respect to finding these things, I would just encourage you first to write the equation in standard form, but from there, find your vertex and determine the value of p. But once you know h, k, and p, we can construct the rest of the curve around those values there and just sketch in to find the rest of what we need to know. Cheers.